Hello viewers, welcome to Elimu TV, a place where you watch and learn. I'm your tutor, Alex Musawa, and I'll be taking you through Physics Form 4, lesson number 27, and our title is X-rays and Production. The objectives of this lesson are to find out how X-rays are produced. Number 2, to find out the properties of X-rays. We have a brief history of X-rays. In 1895, while investigating cathode rays, Wilhelm Conrad Röntgen noted a new ray with greater penetrating power coming from cathode of a vacuum tube and named it as X-rays because he did not know their name. Next, that is a typical X-ray tube, and as you can see, it has a heated filament which emits electrons by thermionic emission, and the electrons are accelerated by high voltage to the anode, and X-rays are produced when high-speed electrons hit the metal target. Next, we have a diagram. As you can see there, those are parts of an X-ray tube. You have the filament, you have the cathode, you have the anode, you have the focal point on the tungsten target. And so, how are X-rays produced? Let us briefly explain how X-rays are produced. X-rays are produced in X-ray tubes when fast-moving electrons are suddenly stopped on hitting metal targets. When a current flows through the filament in the cathode, electrons, as you can see the filament there on the diagram, electrons are produced by thermionic emission. Thermionic emission is whereby when a metal is heated at a high temperature, electrons are emitted. The electrons are accelerated towards the target anode by the high potential difference of the order of about 100 kilovolts between the cathode and the anode. The cathode is concave shaped so as to focus the electron beam onto the target, which is usually made of tungsten embedded onto copper. It is constructive to note that most of the kinetic energy of the electron is converted to heat, with only about 0.5% being transformed to X-rays radiation. The target must therefore be a metal of high melting point, such as tungsten or molybdenum. The anode is made of a good conductor of heat, like copper, to ensure efficient dissipation of heat. In recent models, the target rotates during operation to change the point of impact. Some X-ray machines usually rotate, thereby reducing the wear and tear on it. The tube is made of a strong glass, highly evacuated, so that electrons do not lose some of the energy through collision with air molecules on their way to the target. That's why it is made of a vacuum. The target is set at an angle of about 45 degrees to the electron beam to direct the X-rays out of the tube through a window on a lead shield. The X-rays produced at unsuitable angles are safely absorbed by the lead shield surrounding the tube. The high voltage required is supplied from a step-up transformer. Next, we have some of the properties of X-rays. As you can see there, X-rays are used in medical field. Yeah, as you can see, that is the image of a person's body, and X-rays are able to penetrate through the body. So they have a high penetrating power. X-rays travel in straight lines. Number 2, X-rays are not deflected by magnetic or electric fields. They are therefore not charged. They penetrate matter, with the least penetration occurring in materials of high density like lead. Okay, X-rays blacken photographic films, a property used in X-ray photography. Number 2, X-rays cause ionization of air. When a beam of X-ray passes through air, it knocks off electrons from the molecules on their path. They therefore ionize air molecules, so increasing the conductivity of gases. X-rays cause thermionic emission. And that is the end of our lesson. I have an assignment. Number 1, describe the process through which X-rays are produced. Number 2, What are some of the properties of X-rays? Our reference book is KLB Book 4, 5th edition, 2019. For more information, contact us on our SMS number, on YouTube, Elimu TV, on Facebook, Elimu TV, and on Twitter at Elimu TV _KE. Thank you for watching Elimu TV. Stay tuned.